Hello, hello, hello. Hello. Um, so, Alright, so this is going to be the Desmos webinar okay, so tomorrow we have the SAT, and this is going to be a case to where we can practice. So the agenda for today is that we're going to practice with Desmos. So we're gonna have this little slideshow. It's a few slides only, and we're going to look at it. It's going to provide different skills that you might want to use on Desmos that are going to help you a lot with your skills, your math skills, get your score up. And of course we're gonna have to start soon, so hopefully everything goes well. Like beginning of the session we weren't hearing anything, so we're gonna wait. If you have any questions, ask me. But other than that, we can get started. So, so if you do miss anything, or like I think that you think that I'm going way too fast, you can track back. So, other than that, I think we can be able to start soon. Alright, so we're gonna start. Yeah, okay, so we have quite a bit of people already. Okay, so we're gonna start. So there is an appropriate way to use Desmos, and there is an, I guess, inappropriate way, but there's not really an inappropriate way to actually use Desmos. It's just that there's cases where you can use Desmos properly, and you can save a bunch of time, or Desmos just won't save you. You're just wasting your time. So when to use Desmos though is that you can do it anytime on the SAT. Some questions, like I said, might not be applicable, and 70% of the SAT, I could say, maybe even more, depending on what even shows up, can actually be solved with Desmos, and even more if you know how to use it. So after this, hopefully you're able to improve your Desmos skills, utilize it well, utilize it efficiently. So we're gonna start with our first basic skill that we understand. So it's a calculator. Desmos is a calculator. It's a graphic calculator, and it has more function to itself, but we understand that you can add to it. So we have 9,032 plus 34 equals 9,066. You can subtract from it from the fourth line. So we have this absurd number minus 32,901, and then it will give you that output. Same thing with multiplication, same thing with division. So essentially you can use it like a calculator. Now the case with this is that, like, it's just basic operation. So we can essentially think that there's more to it. Since it's a graphing calculator, it can actually graph functions. So there's some more things. So these are inequalities. This is the less than, this is less than or equal to, greater than or equal to. And there is a case where you can think about it is like, okay, with less than, that would mean that whatever's on the left side will be anything that's below the function of what's on the right. So let's just say 5x is less than y. So we can say that it would appear as a dashed line, and we're gonna see like a 5x like line, and it's going to show like at the bottom everything's shaded. Same thing with the equal sign, but it's going to be solid line, and then it's gonna be the same thing, but with a 5x, if it's greater than, it's gonna show shaded upward. And same thing with this, but it's gonna be solid. These are some things that we can like recognize. So right here, I'm gonna circle it right here. So this is the fraction button. This is going to show you the most simplest form of a fraction. It's going to show you the idea of a fraction. So like, let's say you feel unconfident with a large decimal, you can click that and it will give you a simple fraction. And we have the mean parameter, where you can just type in mean, and then inside the parentheses you type in the numbers that are inside. So if it asks for the mean of such values, you can just type everything out. And you can do the same thing with median, find the center value. You can find the standard deviation. Standard deviation is the mean or the average distance from the mean. So you can find that. You can find the mod, which is the remainder of two numbers. When you divide, you'll be left with the remainder. You can find that remainder with mod. You can find the max value. You can also find the minimum value if you just type in min. So out of this list, you can see that 5,634 is outputted. And we can find the total. So this is basically addition, and you can just add. So another trick, polygon, you can form shapes on Desmos. So you can just have random points. You can assign points. So these are different coordinates. So right here, the black coordinate is corresponding to A. So A is 3.8, comma 253. And I just formed a triangle, you know? And whatever you need it for, you can actually visualize it on Desmos. You don't have to draw it out. SOHCAHTOA. This is very important. Alright, I need you to actually understand this. SOHCAHTOA, it represents the sine, cosine, and tangent. So basically it's an acronym. It mentions where S represents sine, and then the two corresponding letters right after following it is going to represent opposite over hypotenuse. So we're going to have S, so you can block S off, and then it will just be like a slash between each two letters. So S, O over H. So sine means opposite over hypotenuse. Hypotenuse is the longest side. Cosine is adjacent over hypotenuse. So adjacent is the closest side to the angle. Sine is going to be, well, of course, like I mean opposite. So opposite is going to be the furthest from that angle, unless it's the longest side, which in most cases you're not going to find that, because usually with the longest side you had to be apart, like across from the 90 degree. And then so we have cosine adjacent over hypotenuse, and tangent opposite over adjacent. And remember this. So this is not very, like, we're not familiar with Desmos or not Desmos, SAT implementing new unit circle topics. Unit circle is pre-calculus topic, but we haven't seen it yet. It hasn't shown up yet. So in most cases, you're going to have to use degrees. And now the difference between degrees and radians is if you've taken pre-calculus, you can talk about the unit circle. And the unit circle basically determines, okay, so the output of sine 30, well, the sine of 30, it will just output as in degrees. So like we have degrees. So we have the degree function right here. So we're putting in 30 degrees. And the output will be 0.5. So that's just, so sine 30. So we're looking at the y coordinate, because in the unit circle it would be the y coordinate of the unit circle, and then it represents 1/2. So the output would be that. Whereas if we just put 30 in radians, it basically, radians represents anything below pi. So in terms of pi, that's basically how it like functions. So if I can think about it, so like we can do pi, so it'd be like what, 10 pi. So it would probably be approximately 9 pi. So if it's 9 pi, then it's gonna have some output. Okay, so like we're gonna go here, there, and it's just gonna end up as 1. That's not what we want unless it talks about unit circle. We haven't seen any occurrence of it so far, but be prepared. But honestly, so you can see that wrench icon, you can click on it on the test. This is basically what the version of Desmos is going to look like. You can't upload images, audios, or whatever. It's fine, you know. So you can just switch to degrees. And we're going to start. So I'm going to go into Desmos. And we're going to figure out linear. So our first topic is going to be linear equations. So we're going to focus on lines and their functions, solutions, intersections, and questions. So I'm going to hop off real quick and focus directly on Desmos. So we have Desmos pulled up, and we're going to be looking at different ways to use Desmos. So we're familiar with line. So we can say x equals y. So this is a line. Alright, this is a line, crosses through origin 0, 0, and we can shift this line. So we have 4x, so this means that there's an increase rate. We can have 1/4 x, we can have 1/4 x equals y, so that means it just has a little, like, little more wider stance when it comes to an increase rate. We can also shift this, so we can do -4. It goes down, and +4. Now this is the equation of y equals mx plus b. So y equals mx plus b, y is just any value of y, so this is the output. Think of it as the output. X is going to be the increase. So for each increase of x, we have this coefficient right here, which is m. M means slope. So that means whatever increase of x, that's how much y is basically increasing by from the previous term. So let's say we have 1/4 x, so that means each increase of x, we increase by 1/4. So that means if we increase x by 4 times, we're gonna, if we increase by 4 times, you can see right here, from this point to this point, 0, 4, and 4, 5. You can see that, like, that's a distance of 4 units, but it only goes up once. So that's one thing to think about. And we can talk about it with solutions. So one thing that I need to, like, talk about would be solutions. So let's say we consider these two equations. So actually, let's, like, set them equal to each other. So when we have this type of equation, alright, usually it will give you the result. So you can just subtract 6x, or actually just subtract 4x to the other side, and then subtract 4 on the other side, and then you're just left with 2x equals 1. You can divide, and then, so you can say 2x equals 1. It's the same result. So there's this thing called toggle. So you can toggle the line, and you can see from close in that they're the same exact line, so they're the same solution. And this is important because I know, like, there's a lot of cases where you'll run into a problem where we have two things. We have this, so we have one, and we have another. We have two equations. and there's many cases of what they would ask. All right, so that's the point of intersection, and we're gonna look at this. So we have 1 as the x value for the intersection and 11 as the y value for intersection. Now there's a lot of cases where they say the point of intersection is represented with the coordinates a, b. So you're just gonna have to look at each corresponding value. Now there are a lot of cases. Alright, so we can say, okay, they will ask what is the value of a? Well, you have to say 1. And then if it asks what's the value of b, you will have to say 11. So there is another case for this type of problem. If you see this right here, they could ask what is 3x plus 7y? So a lot of people get confused because it's like, okay, we have 3 different things. So we have this and this. What do we do with this? Do we just substitute or something? The case is, no, we don't actually substitute on like these equations. All right, you can. All right, on paper you can, but on Desmos it's better to just graph these. Take this, right? You can substitute that in. So 3, 1 plus 7, 11, and we have 80. So the answer to this is just 80. So we're gonna clear that. So this is one example. So we have 2x plus 3 equals 9. So we have this function, all right? Well, not function. This is actually a solution. If it's just like this means that it's an undefined kind of line because it's completely vertical. There's no rate of change. So the only thing for this usage is to look at the time or the place that it just intersects the x-axis. So this is the x-axis, the horizontal, the y-axis, vertical, and you can see that it's parallel to the y-axis. So that means it's undefined really of a slope. So we have 3, 0. Well, it asks us, what is 6 minus 1? What value would it be? So if we were to like look at it, you know, we have 3, 0 as our solution. You can just look at that. Look at the intersection. Another way. Just substitute. So 3, so wait, not 6 times 3 minus 1. So we have 2 ways to actually figure out such problem. And if you don't know what problem I'm actually looking at, I'm looking at this one right here. So it says, if 2x plus 3 equals 9, what is the value of 6x minus 1? Well, we just found it to be 17. So that's easy problem right there. And there's cases where like you'll find like a one variable question, but it has a different, you know, variable. So we have p. Well, there's 2 ways to actually even solve this. So you can actually just switch it to x, because if we occur with this, it will just say that we only support implicit equations of x and y, and that's just Desmos because it doesn't understand p. So we're going to put it as x, right? Change it to p to x, because Desmos can only kind of understand x and y's, because x is going to be the input, y is the output, and it doesn't understand p unless you just type in such thing like that. So fp equals 5p plus 84, right? You see how it graphs perfectly? Because we have an input. We stated that the input is going to be p, and it's going to be helpful for any case that you have a case of a different variable. So just keep that in mind. So we do have this original thing. We can take it as that, you know, but we're going to leave it as 5x plus 180 equals 250. The real solution, like, you can just subtract 180 to the other side. So 250 minus 180 is 70. 70 divided by 5, so it's 14. So we're going to look for this right here. Whatever it intersects, that's the solution. And right here. And we're going to change the color, actually. We're going to change it to red. And we're going to change the thickness to 10 right here. you can see right here, it's 14. Alright, and that's going to be the answer to such problem where it asks what value of p, alright, we're just going to return p right here, satisfies the equation, or suffices, so the equation 5p plus 180 equals 250, So that's another method that you can use for Desmos. Now there's another way to use Desmos, and that's to compare answers. So let's say we come across this question right here. So we see which equation has the same solution as the given equation. So we have 7, 2x minus 3 equals 63. We can just type that in right now. So we're going to have 7, 2x minus 3 equals 63. So we have this solution right here. Now we're going to look by typing each and every single one of the answers, and then we're just going to compare which one actually is similar. And how we can tell that's similar is if a line is crossing. So we're just going to increase each and every single one, and so we're going to say that's 10, that's also 10, that's 10 as well. So 2x minus 3, 2x minus 21 equals 63, and 2x minus 21 equals 70. So we're going to look at this right here. Alright, so we have 4 lines. Now here's the thing. We typed out 5 cases. So where's the last line? Well, the last line is actually going to be behind one of these. So you're just going to have to see, okay, look at each one. So we're going to look at the green one. There's no other line, so that means that's not the answer. We're looking at the blue one. There's no line. There's no answer to that. Red, no answer, so that's not the answer. Last but not least, oh, there's a purple line right underneath this one. So that means that's going to be the answer. So right here, hold up. 2x minus 3 equals 9. That's the answer to that problem. And then we're going to discuss a new thing that not a lot of people know about. We're going to talk about infinite solutions. Oh my god, it's infinite solutions, no solutions, and one solution. So we're going to look at this. So 4x plus 5 and 4x plus 3. So this is going to be an analogous situation. So we're going to talk about, okay, so let's say we have 2 identical runners. They run the exact same speed forever. But let's say this one runner starts at the 5 meters and this runner starts at the 3 meters. If they run the exact same speed, that means they're going to be the same distance forever and ever and ever. Is there going to be a time where they're gone, they just don't intersect? There's never going to be a time because they're running at the same speed. Look at it, it's parallel. And when we have parallel lines, that means they don't intersect. Intersection will mean a solution. There's no case of an intersection, so that means there's no solution. Now, what does it mean with infinite solutions? What does that mean? So let's say we type in a problem. So 4x plus 5, and then we can say, let's say 20x plus 25. Well, actually, that's wrong. Let's say we have 20x plus 25 equals 5y. So we're going to look at this. So we see this, right? So we see this line. And you can see that the black line is the same line. They're both overlapping. You see, like if one disappears, the other one appears. If they're both gone, they're both gone. That means that for each x value, it represents the same. So we're going to see it that every time on the line, we're going to see that there's an intersection every single time. That means that there's infinite solutions because let's say it's the same identical runners, but they start at the 5 meters this time. They both start. If they start running and they're running at the same pace, that means that they're neck and neck. They're literally right next to each other. So let's say for infinite amount of time they're just running. Each solution, let's say, is a point where they're just intersecting. If they're next to each other all the time, infinitely, they're just running and running, and they're just going to keep being neck and neck. That means that they have infinite solutions because there's not a time where they just leave each other. Now, this is going to be the easiest one to explain. One solution, one intersection. Alright, they have different rates, they have different stops. Alright, if they have different rates, you can tell by the slope, they're going to have one solution. And it's going to be that, and they're never going to touch ever again. They just go away. So, we're going to do a little question right now. So, we have 2x plus 16 equals ax plus 8. So, we're told that there is infinite solutions. So, that means they must be equal. So, these 1 equals 2. That's not how it's like f of x equals g of x. Let's just say that one side is f of x, one is g of x. So we're going to say that since these two equal each other, we're going to have to click on like that. So, okay. So 2x, and then we're going to have ax plus 8. And then we're going to look at this. So what type of equation? So this is a slider right now. So if you don't know, if you can actually do this, g equals 3, you can add a slider to your line, and then you can increase or decrease. I forgot to mention this, by the way, but this is very useful to like determine something like this. So let's say I want to like look at what value of a will equal will make these infinite solutions. So that means they're going to be overlapping. So if we just decrease this, it's not looking close. We increase it, and we see that every single step we just get arbitrarily close to the line. And then when we stop, we can see that a equals 2. That means our answer is 2. So the value of a is 2. It's a constant. But there is going to be a little sneak. So we're going to look at this. So we have 2x plus 16 again, and we're going to do this side. So if you look below your escape key, you're going to see a little squiggly line. If you press shift and then tap it, you're going to present the squiggly line. This is called the tilde, aka the linear regression symbol. This will help you a lot on the SAT. This will help you approximate, because linear regression basically means that Desmos tries to approximate each and every single value that's inside the functions that you're trying to make similar of. So we have 2x plus 16, linear regression, ax plus 8. Now this doesn't work. X may not be used as a regression parameter. The reason why is because x will be x. X will be infinite many numbers. You can just have any of these numbers and it will represent x. But regression represents as for each and every single value. Like, it's not each and every single value, it's only a constant. So we can represent x1 if you just type in a number right after x1 and x1. Now, it doesn't have that. Now the problem is that a has to equal out to this function right here. But if that were to be the case, that means, it just wouldn't work out, because x1 is just a constant. We want it to be random. Alright? Random is a function. So right here, hold up. Did I break Desmos? Oh, it's because, oh, a little oopsies. Alright, so I already had a set value for a. So this is basically the representation of linear regression. So we basically have 2x1 plus 16. So this is represented as a constant, and a, x plus x1 plus 8. Now here's the thing. Yes, brackets. Yeah. With this regression, x1 is considered a constant. We don't want it to be a constant. We want it to represent for however long, because some cases x1 will just be some crazy number because it tries to approximate each and every single constant inside these two. So like it will try to look at this one and then this one and try to approximate a constant for each and every single variable there is. So we're going to have x1 equals random 5, or 54 actually, and this basically gives you 54 different values, which Desmos actually substitutes in order to like approximate each and every single variable. So that's a little intro to regression. We're going to talk about that a little later. So in any case with the tilde though, it must have infinite solutions. So for example, if we have 4x plus 5 and 6, or like ax plus 91, these don't represent infinite solutions. This is actually parallel. Well, like if we just try to type it out, so let's say there's no solutions, so we just have ax plus 91 and then 4x plus 5 here and here, and that's completely wrong, because if they're parallel, if they have no solutions, they wouldn't intersect like that. They wouldn't. All right. So what's the problem? What do we need to do? Well, we gotta unconsider this. We can't consider the thing that causes it to be parallel, because if you consider that, that means it kind of affects the slope. We gotta not consider those two, because that causes it to be parallel. And you can see that if we can just do random again, 4, and you can see that a equals 4 right here. That means that they're parallel. So if it's infinite solutions, you don't need to consider that, but if it is no solutions, you have to consider that. Okay, if there no solutions, that means they have to be parallel, so that means these two cannot correlate out. So that's one trick for y'all. And there's another thing with trying to set two equations to each other. So we have, let's say, 15 minus 9. So 10 times 15x minus 9, and we're going to set that equal to negative 15, 6 minus 10x. Where's the line? Well, we can realize that there is not going to be a line. You can see right here that if we have a 15 and 10x right here, there's no solution, because let's just say, okay, so we can distribute. So 150x minus 90 equals, or let's do a separate line. So minus negative, okay, hold on. We got Desmos for reasons, so 90, yeah. So we got negative 90 and plus 150x. If we have these equal to each other, we can add 90 to the other side, and we can subtract 150 on the other side. It's just going to be 0 equals 0. Now that is not representative on Desmos. Don't know why, don't know when, or whatever. So we can have that, or in some cases we can have that. That's not even true. So any two cases, so it's just 0 equals 0, or the two numbers don't even actually match up, it just ends up with Desmos not graphing it. So what do you do with it? Well, you can copy and paste it onto a different line. So we do have the same solution. So we're going to look at that, and we're going to see that it has 0.6. Oh my god, hold up. Dang, that's a good crack. Yeah, so type it out. So you want to type these out on separate occasions. So we're going to change this. Ooh, whoa. So they're both crossing each other. Let me change the line actually. So they both cross. Same point. Alright? If it was a case where it's like that. Oh wait, what the heck? It's fine. All right, we have 10x. All right, they're both the same solution, so that means it's infinite. There will be infinite solutions on this case. Whoa. Someone said something weird. Yeah, so there's cases where they can be infinite solutions or no solutions. You have to just graph the function. All right, so these are really steep graphs. So you can see right here. Let me actually change it. So we're gonna have. We're just gonna change it to x and x. So that would be 10. So we can consider it's like 10 over 15, right? Right, we're gonna see it right here. That's a better example. So you can see right here, they're infinite solutions. They represent infinite solutions because they're overlapping each other, and that's gonna be the same case. So like, let's say it's not like similar. So let's say that's 10. You have to type them out like separately to understand that if they're infinite or parallel solution, no solution graphs. So we're going to focus on another topic. We're going to be discussing parabolas. So we are looking at a parabola right now. Oh god. So what you want to do, usually they'll give you something like this. So f of x equals x squared plus 3x minus 5. So each and every single value will represent correspondent to this equation, plus bx plus c. So each and every single one is correspondent. So whatever the coefficient is going to be the coefficient. So that's technically 1, coefficient. There's nothing there. So I want you to notice something. C right here and -5. So we can see the -5. We can see that that's the y-intercept. It's similar to y equals mx plus b. That without the coefficient, like with no variable attached to it, that will be considered the y-intercept. That's case for most formulas, for most equations. So that's one way to think about it. So we are gonna talk about solutions. So we have two solutions right here. Right? If you want to graph, you can. Thankfully, you can graph. You can graph these equations, so you can see that there's two intersections on the x-axis. These can be called zeros, solutions, or zeros, solutions, whatever. I don't know why I just did that, but you can basically look at it and realize, okay, there's two intersections. Now let's say there was only one intersection like this. You'll realize that, okay, so it intersects once and never touches again. That would just be one solution. So in cases like this with parabolas, there can only be two solutions, one solution, or no solutions. And there is a formula for this. So there's square root -b plus 4, or actually minus 4. No, wait. B squared minus 4ac. That's the actual formula. So this represents, okay, so if it's 0, if whatever this evaluates to right here, so let me copy and paste it. If this equals 0, that means there's only one solution. It's just going to be like this. And that's pretty accurate. So there's no B, there's no C, so it's just going to be 0. Let's say it's greater than 0, so it's a positive value. That means there will actually be, okay, so right here is 3x, two solutions right here. So that means this is representative for two solutions. This is for one. Now this, if it's negative, it's going to evaluate as a negative number because, or imaginary number. You can't square root an imaginary number. So that entirely will mean that there is no solutions at all. So 3 right here, you can say, okay, there's no b value. That's 0 minus so it's already automatically minus, so it's negative. So if you try to square root it, it's an imaginary number. It gets a little wonky, but yeah, you'll realize that, okay, there's no solution in that case. And I want to like show you that, like, okay, even if you have this, it makes it so much easier. So let's say you want to find the value of 10. So we can say, okay, f of 10, it just substitutes as a place. So x is just going to be the placeholder. We just place in 10, substitute it, and then we can just say, okay, 10 squared, so all it goes through is just 10 squared plus 3. It's the same value, so it just basically substitutes it in. There's going to be some other cases where sometimes you might not find the solution, but you just have to use a little bit of brain power. So we can graph 8x, for example. So if we graph 8x and we're asked for what value of x, this can be anything. So this could be for like parabolas, weird funky graphs and stuff. We can say, okay, so for what value of x is f of x, let's say, equals 72. So if we want to know that, we can say, okay, so f of x can also be known as y. So y equals 72. We can just find 72 right here. Oh, intersects at 9. Oh, would you look at that? 8 times 9. It's going to output to 72. So for that answer, it's just going to be 8. And there's some questions that actually talk about something like this. So like they have A0 and they have 0B. So this represents the y-intercept, because actually not the y, the x-intercept, because this x value actually has something, but the y value does not have anything. So that means it doesn't represent anything, so it doesn't go up in any case. So you're just going to be looking at something like this. Right here, it's just scrolling through the x-axis. So whatever point, let's say, crosses 5. Yes, pretend that's 5, and not 45, 5, and you're going to see that, okay, that represents there. And then we can add the slider for b, and we can see that it's not increasing on x, it's actually increasing on y. And sometimes it will ask you some questions. So let's say we say 4x plus 28, and it's asking for the solution of 2 of those. So we can say 7 right here, negative 7, and then we have 28 right here, because that's the intercept. And we're going to be looking at it. So we're going to say, okay, so it asks for the solution of a and b. So it just asks, what's a plus b? We just got it already. I didn't even mean to do that, but we basically just got the answer. It's 21. We just literally took it into consideration. Let's say we don't have these sliders actually. Well, we can represent it like this. So we can do this, and we can do this. So we can say, okay, so this is 28, and this is negative 7. So if you just add those together, so 28 minus it's negative 7, so it's just 21. Alright, so it's just the addition. Basic addition. Tables. This is a good way to actually, okay, so you can click on the table and you can actually type out values out for this, and then you can actually like have Desmos graph it for you. So 137, 192, and 247. And then we are given that f of x equals mx minus 28. Alright, so it asks for what is the value of m. So we're just going to regression that, and off the bat we can tell, okay, so y equals 11x minus 28. That's corresponding to that. And we can see that, okay, m and 11 are corresponding, so that means the answer is already 11. You can use a table for any case. So you can have the table, so we can say some wonky numbers, so 1,000 and stuff, and then you can do quadratic regression, so just like that. You can do cubic, you can just, do a lot of stuff, but usually in most cases that you're just doing a linear regression, or you do a quadratic regression. What else could you do? Okay, so one solution with 2 lines or 2 graphs. So let's say we have this one, 4x squared plus 64x plus 262. So we have this, and we want to know for what value. Oh wait, that's the different. Okay, whatever. So we have the shifters. So transformations are important on the SAT as well. So let's say we have f of x equals that. We can do many things. So we can do x minus 5, so it shifts it to the right. We can do x plus 5, it shifts it down. Alright? It just asks for the minimum, but we're going to be looking at something else. We're going to find an equation that, we're going to say mx plus 10, right? And we're going to have this. We're going to try to find something that is tangent. So we're gonna try to. Okay, that's close, but not entirely. Okay, so we can do 0.45, 8. All right, I did it wrong. Right, whatever. Let's just consider. Okay, 4x plus m. We're just gonna say that's m. So this is our line. We can get arbitrarily close. We're just gonna say that's 100, right? And we're just gonna try to reach it here. So just a little bit right here. It can ask for what point or what value of m is it where there's just one solution and one solution only. So it's not giving to me. 38 will be too far. 36 will be too out. 37 is. That's not enough. 37.5, 30. We can just okay, whatever. It's 37. Oh my god. Okay, 0.4. Okay, I think that's okay. That's one solution right here. All right, we found one. Nope, never mind. Okay. Basically, you can use the slider to just approximate. Yeah, I think it was 37 though. So. We're gonna look at another case. Percentages. This is gonna trip a lot of people. So we're given that A is 2241% of B plus C. So we know that. Okay, so from this sum, A is this much greater in percentage. So we can do a little function. So we can say, okay, we're gonna do bracket linear regression. So we have A, and then we can say 2241%. Say is 2241% of. So there's a function called percent of. And we can say 2241% of B plus C. And we can regression that and then say that's A. And we can also say that we have another list. So this is called a list. So we have multiple cases of it. So basically there can be multiple equations in this list, and then it will basically represent whatever we need. So B and C. So we have B is 83% of C is B, and what percent of B is A. So we're given that, we're gonna set some boundaries. So we're just gonna say that's greater than 0. Let's actually do it in here. B is greater than 0. C is greater than 0. And then we can see, okay, what percent of B is A? So so what percent, so we can say like, okay, K percent of B, or what percent of B is A? So we can say K percent of A, and then we can say B. So it's gonna be like, it can be this wonky. You know, there's approximation. Wasn't familiar with it as much, like compared to this. So you can like type out like a lot of the case right here, and basically all you really need to do is just type out, okay, what number it is. So let's say it's just 2241%. So we have that, and then we can just type out, okay, whatever of that. So 2241% of B, and we can say that equals A. So regression to A, 2241% of, let's just say, let's do something like, say 20% of B is A, and we have a boundary of A greater than 0, and B is also greater than 0. So we're given some number, you know, because this is linear regression. We're just approximating, and it's not this is not the greatest like lesson for it, but it helps to know about it. Oh god. So that's just like one thing to note, right? If you have been taking notes. And we're going to talk about a little more about linear regression. So there's two ways, there's actually multiple ways. So we have listed linear regressions. So this is where we can type in multiple equations in once. So 4x1, and then we can say 5x1, or like, and then we can say 6, and then 90. So we can see it tries to approximate. We can, only case for this though is that like in x1 you can't do list inside list. So you can't really do random. You can't do that, unfortunately. But you can do the same thing here, so you can just like type it out randomly. So 4x1, that's 66. What the hell is this? Okay, I just got like jumped. Okay. Alright. Oh, I think we're good a little bit. Yeah, there's not that many good examples, so that I can think of right now. But 4x1, okay, so you can try to regression this. So like, let's say we have 59 x1 squared, and then minus 90. So we have this little approximation. We can say, okay, x1 equals random. We're just gonna type it out right here, 5, and then we can see that, okay, it's a little random. All right, A represents as negative 275. All right, there's some approximation that's similar. So it just Desmos just tries to approximate for each and every single value. And yeah, so I think it's a good time to actually start practicing using Desmos. I think best way to actually like learn Desmos and stuff. So I think that's like all I could really like discuss. There's a lot more I could say. So like, for example, like we could say like the x minus h squared, this is going to be the circle formula. So like y minus k squared equals r squared. So like, for example, if we just type out like, okay, we're just going to copy and paste that. We can say 3, 7, 9. So we have a circle right here. And if we're trying to figure out like, okay, so we have 12 and 7, So we're going to say A equals 12, 7. And then we can figure out the last point, so negative 6 and 7. Oh god. Alright, so we have that. So we can take two things. So we can do distance of the two, so AB. So that gives you 18. And now look at this. This is radius. So the distance between this is called the diameter. And oh my god. Okay. So the two. So there's 2 points, and these are going to be known as the diameter. So if you're trying to figure out the radius, you just do divide by 2 because the radius is the diameter divided by 2. You can also do midpoint formula. So like if you're trying to figure out what's the midpoint or like what's the center, you can do A and B. You'll be greater with 3 and 7. And can you believe that 3 from here? So like you can say, okay, so since it's already negative, this would actually be considered positive. This is already negative. This is positive. So you see 3, 7, 3, and 7. And I'm just going to load up a practice test, and then I'll just show you how easy it is to just use Desmos and, you know, actually pass the exam. Alright, we're gonna... Yeah, if you have any questions, type them out in the meantime. Alright, just loaded it up, no questions so far. So basically if you want to just like do practice, you can just skip the modules. You know, it's pretty light. Can probably answer this. Predatory differ widely in how they food for the young provide. Okay. We can just do a little bit of English practice right there. Okay, we can just resume testing. Okay, first question. Alright, what is the y-intercept? Alright, so you're just going to look at this. So we know the y-intercept is just the time that it crosses. So it wouldn't be any of this because that's just when it's 0. So that would be considered as an x-intercept. X-intercept right here, so those two are wrong. These would only be considered y-intercept. Just look at it, it crosses 8 right there. Boom. Desmos. Right here. So we're given that f of x equals negative 3x plus 60. So we're given that, what is the value of f of x when x is negative 8? We already got the answer, 84. Alright, go, go, go. Alright. Producer is creating a length 70 minutes. Video will consist of segments that are 1 minute long and segments that are 3 minute long. Which equation represents this situation? So we're given that, okay, so we have a total of 70 minutes. So we can do total of 70 minutes. And we have videos that can be 3 minutes long, and there's one that are 1 minute long. So X represents 1 minute long videos. So, and then Y represents 3 minute long videos. So we can just consider, okay, so we're going to do X, so that's just the 1 minute ones, and then Y, so 3Y, so it's just going to be 3 times Y because those are 3 minutes long. So we're just going to go to the next question. A bowl contains 20 ounces of water. When the bowl is uncovered, the amount of water in the bowl decreases by 1 ounce every 4 days. If 9 ounces of water remain, so we can do, okay, so we do 20 minus 9, so we know that's 11, and every 4 days 1 ounce is No, so 11 has been basically gone. So we can consider, okay, so every single day 1 ounce is removed. So in this case, it's every ounce, so it's like a 1/4 slope. Think of it as a 1/4 slope. So it has a rate of 1/4. So we had to multiply by 4. It would be 44 days. Okay. This one you really just have to have some stats knowledge. Each of the dot plots shown increase represent glue sticks, rod. They're practically the same deviation, so they're gonna be equal because they're basically the mean. You know, they don't differ as much, so they literally don't differ at all. So it will be equal. Desmos right here. You don't practically need Desmos. I can probably solve it, but alright, you can just type it out. So minus 6x cubed minus 3x, right? You can just type it out. So x cubed plus 10x. Not the case. Negative 13x cubed plus 10x. Not the case. Negative 13x cubed plus 4x. That is not the case either. Final one, alright? X cubed plus 4x. Okay, I might have typed something wrong. X cubed. Yeah, I did type something wrong. Yeah, it's 4. Alright. Okay, it was. Okay, it was the blue function. So it was the top, bottom one. I did type something wrong, but it's right here. Human error does occur. The answer is A. ABC, the measure of angle A is 54, the measure of angle B is 90. What is the measure? And the measure is K over 2. So we gotta consider, okay, so a triangle has a total of 180. We just subtract 90 minus 54. We have 36. 36, linear regression, K over 2. K is 72. What is one of the solutions? So we're given that, okay, I can use Desmos for this too. Like, this is literally solely for Desmos, so we can just give out. Okay, so we have all these. We have 3 solutions. So negative 5, that's not 1 present. 0, 0, that is present. 4, not present. So we can go to the next question. Chemist combines water and acetic acid to make a mixture with a volume of 56 milliliters. The volume of acetic acid in the mixture is 10 milliliters. What is the volume of water in the mixture? So we know that, okay, there's a mixture of 56, and then the volume acetic is 10, so that means we're just left with 46. We're just speed running it, you know. Distance of 354 furlongs is equivalent to how many in feet? So 1 furlong is 220, and 1 yard is 3 feet. So we can just do 354, 220, right? 220 and 30. So we're just given this long digit. What else? The y equals 2x. Okay, this is another. This is the case of just plotting them. So y equals 2x minus 1, right? They don't intersect, they start at different rates, 0. 13%, okay, so 13 is p percent of 25. So we can say p percent of 13, regression, 25. That is completely wrong. 852. Okay. 13 p percent. Okay, p percent of 13. Do linear regression. It's very odd. Okay. Right, and we can just flag it right there. You know, like worth it, we can just solve it anyway. Yeah, so the answer is 52. In consideration, you just gotta like consider, so like 52 divided by 100 times 25 equals 13. You just gotta like look at it. Okay, so like P divided by 100 times 25 regression 13 52. There is a shortcut, but we're trying to save time, you know. And how much time does it take to double? So you gotta look at this. Okay, so like for it to be like 1, so like 1 could, so like anything to the power 0 is just 1, and then if we have 1, then it's just gonna double, so it's gonna take 410 minutes, or yeah, minutes for that. So we're just gonna look at that. Increases by 49%, so it's increasing exponential because it's taking the value of the previous year and multiplying again and again. We have a circle with endpoints 2 and 4. What is the value of R? So we can actually just do A equals 2 and 4, B equals 2 and 14. Take, you can take the midpoint, like midpoint A, B. We are given 2 and 9, so that's accurate, but we just want the distance. So distance of A, B is 10. That's not the answer though, because you have to divide by 2. The answer is 5. That's the radius. RST, measure of these angles are 90. Sine of R. So sine of R is this over that. So square root of 15 over 4. What is cosine of S? So the sum of them. Okay, so that means we're told that T is basically the 90-degree angle. So since we have the 90-degree angle, so we're God. So we have cosine S. So sine of R is that, and cosine S. So basically, we can say that they're both correspondent. So this and this, so they're both adding to 90 degrees. So they're basically correspondent to their side length. So it's just square root of 15 over 4. The given equation relates to distinct positive numbers pk and j. Which equation correctly expresses 4j plus 9 in terms of p and k? So in this case, you just really gotta do something else. But 4j plus 9, you can just do kp. You can substitute too. Because like these are all can be placeholders in themselves. So you have this. Okay, this is this case of greater than, so everything must be shaded below. So 13x minus 18, actually greater than, so it had to be shaded above. So you can consider this, so like you can like do a table real quick. So like 13x minus 18, 13x1 minus 18, so we have 3, so that's 21, so that's just incorrect itself. That's incorrect as well. And then we're given 5, it should be 47, so the answer is that. Line L is defined by this. Line N is perpendicular, so perpendicular means that it strikes it in a way that's just 90 degrees, right? And so we look at this as 3y plus 12x equals 5. So we have a negative slope right here. So really you can just do that. So the slope is negative 4, and when we're talking about like a perpendicular, you're just going to take the negative reciprocal. So let's say we have a over b, that's just going to convert to negative b over a. So we're just going to have 1 over 4. If that's the case, right? It should be 1 over 4. So like equals negative 12x. Yeah. And we have so much time left too, and it's crazy to think about that. So how many distinct x-intercepts do we have for this graph? So you have to look at this, right? Because really, like, Desmos will help you, but like you have to kind of like take an account for each one. So we have x minus d, so that's one case. X plus d, that's another case. X plus g is another case, but that's a repeat, so we just have 3 only. For the exponential function f of 1 is k, is that. Which of the following form shows its coefficient? So we know that k. So okay, so f of 1 is just gonna be k. So if it's just k, that means it's gonna consider, okay, so like anything to the power of zeros, that is just 1. So if it's just x minus 1, in the case it's just k, 128, it would just be 128. It will produce 128. 4x squared plus 64x plus 262. Okay, we have this function, so f of x, we're just going to use that. 4x squared plus 64x plus 262. Right? So this is our minimum? No. We got to take into account f of x plus 5. Just graph that. Negative 13. And we just completed it in like 10 minutes, alright? We just completed that in 10 minutes. Using Desmos, using our brain a little bit. Alright, so we're getting to our second. So which equation has the same solution? So we can just type it out again, you know? So like 4x plus 6 equals 18. And then we can just do this. So like, okay, 4x equals 108. 4x equals 24. I don't really want to deal with this, but I know it's 12. So right here, look at that. Okay, speed test. The total cost, f of x in dollars, to lease a car for 36 months from a particular car dealership is given by f of x equals 36x plus 1,000, where x is the monthly payment in dollars. What is the total cost to lease a car when the monthly payment is $400? So we have this function, so we can just grab it right here. So f of x equals 36x plus 1,000. And to lease a car for 36 months, and where x is the monthly payment, what is the total cost to lease a car when the monthly payment is $400? So x is the monthly payment, so it's $400, and we had to multiply. So we had to just say 400. Got the answer. Graph. Just literally just goes straight to Desmos and graph equals 297. And now it's shifted 5 units down. So it's gonna be crazy. So that has been shifted down by 5. Wait, actually we can just do this. So like minus 297 equals f of x. Like, okay, this is actually a really bad one. Okay. Okay, I got it. Alright, so we can just type it out. So like 27x plus 33y equals 297. Well, in this case, you can just subtract there and then just divide it. So we can have negative 27x, but that's also divided by 33. And then we can have plus 297 divided by 33 equals f of x. So f of x right here right there. Okay, so we have our function, and now it's asking for what is the y-intercept. So we didn't really that. So we have to shift it downwards. So if you could recall, that would just be like that. So if we just shift it, it'd be 0, 4. Alright, it's literally just another graph. 110x minus 2. What do you look at that? Minus 2. This is just Okay, alright, so we have. This is an interesting case. So we have 480, and we have to find a way. Okay, so like, we gotta consider that. Okay, so each case, we have to like, we can graph it out, so like, which one looks similar to it. So 1ax plus 12. This goes increase. We don't want increase, we want decrease. So 8x plus 12y equals 480. It's very similar. Where does it intersect? 40. So that's answer that we can consider. 12x plus 8, that also increases, so that might not be an answer. 12x plus 8y equals 40. 40 is decreasing, but it has 60, so we know that the answer is that. 7.5. Oh god. 7.5 x plus 6y equals 25. You can do the same thing here. So 5 half x plus 6y equals 23, and it asks for that value. So we're just gonna look at the intersection. So 2 and 3. So it asks 17 over 2 times 2 plus 18 3, because that's the corresponding variables. It asks for 17 half x and then stuff, and then equals 71. X plus 6. Okay, so we're just given that. Okay, so we're given this. F of x equals x plus 6, x plus 5, and x minus 4. Now, if we do f of x minus 3, we're given the same things, and we just want to figure out, okay, we can actually make a table for it. So, f of x minus 3, actually be x1 minus 3. And we can just type in equations for it. So, negative 5 and 4. Oh, negative 3. Would you look at that? Decrease it by 45. So you just want to find something that's like, okay, 1 minus, so it's like that. I mean, you can figure it out with Desmos, but like in most cases, that's not gonna be like, you just gotta like realize the fact of that. Submersible. Okay, so we're looking at this. It gives the depth in meters. How many minutes after collecting did it take for it to reach the surface of the ocean? So we could consider that. Okay, so it takes however long. So we're just gonna type in negative 155 x plus 19 x minus 35, and then really the like thing is that like after x minutes, so it basically kind of excavates. So we consider it's like, okay, so after 8 minutes of collecting, it reaches there. So gives the okay. A cube has an edge length of 68 inches. A solid sphere has a radius of 34 inside. So this is like more of geometry. So like I'm probably gonna skip it. Like if you don't understand the question, just skip it, because like you can probably use Desmos on it, but like I'd rather spend my time using Desmos for easier questions. So x plus 1, you know, do that. Minus 56. 4x1, x1, minus 7. So we're, oh shoot. We gotta doesn't even let me copy and paste. That's wonderful. 4x x minus 7. So I didn't see, it's like, okay, it says the sum of the solutions, so you gotta see, like, okay, what 2 times does it cross? So it crosses here, and ooh, that's a crazy value. Crosses there. So what is the sum of the solutions given to the equation? So we're given these two, and really all we have to do is just like add them together. So the solutions usually are just going to be the x value. So we're just going to have 2.66666, which is like 7/3. Not 7/3. It's going to be 8/3 plus 7. So then it's just 29/3.